Welcome students to the sixth tutorial of the database concepts and design. Our today's topic is about the structured query language SQL. SQL, as you know, it's a standard language for the relational databases all over the world. So let's start. The objective of our today's, we have 6 objectives. We will create, alter, drop, describe the tables using the SQL commands. Before that, we already create some tables and the database objects, but using the graphic user interface of the Apex. Today, we are going to create the same database objects using the SQL command by writing the queries. So after that, we will create rows by using the insert statement. We will read rows by using simple select statement, update the rows by using SQL commands, and delete the rows by using the SQL command. So all these objectives and the activities are the basics of the SQL. So as you know that we are using the Apex, Oracle Apex for all these exercises. So structured query language SQL is a programming language which is designed to manage or communicate with a database. We have, SQL is divided into different categories or the types. So the two main types of the SQL are the data definition language, DDL. This is used to define the structure of the database, like create table, alter table, describe table, and drop table. All these commands are actually affects the structure of the database. So that's why we call it DDL commands. Another is the data manipulation language, and it is used to manipulate the data of the database. Manipulate data in the database by using some commands like create row by using insert if we want to create a row. If we want to read the data from the database, we use the select command, which is the most commonly used DML command. If we want to update some already entered data in the row, we will use the update command. And finally, if we want to delete some record from the database, we can use the delete row command. So before we start our actual exercises, just have a look at the Oracle data types. So built-in data types in Oracle can be divided into 6 categories. Character, numeric, date, LOB, RAW, long raw, ROWID, UROIWID. We will concentrate only on the first 3 in this tutorial. So let's see. The first one is the character. So character has character data types are divided into char. So char data type stores the fixed length of the characters between 1 and 2000 bytes. For example, if your column name was defined as char 20, so a value Ali will still be of the length 20 with 17 padded spaces. The second subtype is the varchar 2 varchar. So this type of data is, as the name implies, var is the short form for the variable. So it is the internal data type. It can be extended or variable. So they store a variable length of characters between 1 and 4000 bytes using the same example above, but with name column defined as varchar 220. So Ali will be only of length 3, right? So this is the difference between the char and the varchar. So the only difference between the varchar 2 and varchar is how they see null and empty string. The first one treats them differently while the later as the same. So it is suggested that we use the varchar 2. The third subcategory of the character data types is the nchar and nvarchar 2. So this type stores the Unicode characters. nchar can hold 2000 bytes while nvarchar2 can extend up to 4000 bytes. The second data type is the numeric data type. So the first sub data type of the numeric is the number. It stores fixed and floating point numbers up to 38 digits of precision. You may optionally define its precision, total number of digits, and scale number of digits on the right. So for example, the grade column can be defined as simply number or number with its the precision values. Second subcategory of the number data type is binary float. Binary float stores a 32-bit single precision floating point number data type. Another is the binary double, as the name implies. It stores exactly double 64-bit double precision floating point number data type. The last is the date data type, which stores both date and time values, and it specifically stores the year, month, day, hours, minute, and seconds. So most of the time we use the toDate function to store a date value. Here we can see the two examples. Like the toDate function, in the first example, it is March 18, 1990. So this function stores the date with all zeros for hours, minutes, and seconds. Second is you can say the toDate function stores the same date, but it stores the complete set of date and the time. The time is shown here, 12:45 a.m. So this is the short introduction or discussion on the most commonly used data types provided by the Oracle. Now let's discuss about our today's activities. We have two main activities. The first activity is based on the DDL commands, in which we will create two tables called students and teachers, right? We will create, because I tell you the DDL part means DDL commands are used to describe the database, affects the database structure. So after that we will drop one of the table, teachers, and then update and describe the student table. So in short, the first activity is based on DDL commands. Our second activity is based on all DML commands. Like first, when we create the table, now we will insert the data in the table. We will insert two rows in the student table. Then we will update the first row. Like already we put some data, then we make some changes in it by using the update command. And then we see if we want to delete some data, some record from the table. So by using the delete command, and we will practice with the select command, right? Okay. So this is our first activity. In the first activity, as you see, we need to create, describe, update, and drop the table using the SQL command. So the first task is to create. So actually, activity 1 has 4 subtasks. So the first task in the activity 1 is to create the tables. So create two tables. We are going to create two tables using the SQL command. This is our first table, which is students table, and the second table which we need to create is the teachers table. Now look at the requirements over there and the definition. Each of these tables have 3 columns: student ID, student name, and student age. And the definition is here. We select the student ID as a primary key. And whenever, as you know, that whenever we define the column or column in our database, we need to provide the domain of that, which includes the data type. And if any kind of constraint we want to attach with specific attribute, we have to define it. So you can see each of these three columns have their like student ID, the data type is number. For the student name, the data type is varchar 230. This 30 is actually specifies the length of the data, right? So it is very important that you should specify the specific name according to the requirements. Like, as you know, that if we are not specifying the length, the database will reserved the all the space related to that, and in this way it is a misuse of our resources. So it's better to define the length of the variable, unless you don't have an idea, right? Or maybe, but we have to collect these requirements. So we should not, we should avoid reserving the extra space in the database. The last is the student age, and the data type is the number. The same we are going to create for the teachers table, like the teacher ID is the primary key, the data type is number, it should not be null. Name of the teacher is varchar 230, and the teacher's nationality or maybe the age is varchar 230. So these two tables we are going to create now using the SQL commands. So let me take you to the Apex. Now, I hope you can see here what you do when you log into your Apex. Go to the SQL workshop, click SQL commands, and it will take you to this screen. Now you can see here, you will write the SQL commands. This whole screen you can see is divided into different sections, and mainly you can have this is actually the editor screen where you are going to write your code and debug it, execute the commands, and you can see the screen is divided into different sections. So like the first, here in the first upper part, we will write our SQL commands, then we run the queries, and we'll see the results in the lower part of the screen. So let's start. We are going to create two tables, right? So for creating the database object, table is a database object. So that's why we are using the create command, which is the TDL command. So create table. Okay, create command has create table. What is the name of the table? The name of the table is the students. So girls, you see the create table, these two words are in red color and this is in the white color, which means that these are the reserved or the keywords, right? One more thing I will tell you, that the SQL is not a case sensitive language, but by convention, we write the reserved or the keywords in capitals. If I don't write this create table in the keyword, still it's a keyword. But for the sake of understanding, I'm writing these keywords in capital letters, plus you can see the Oracle, or take it as a Oracle also find it that these are the keywords, so they are in red color. Okay, so the name of the table is students with 3 columns. So I'm starting with I put this, the first column is the student ID, right? Name of the column. Then what is it? The data type. And the constraint we see is the not null. So this is my first column, but still I have two more columns. So I separate this by the comma. Now, second is student name. Data type is varchar 2. Length is 30. One more column. Student underscore age. And the data type is number. And we are done with that. One more thing, we have a primary key. Primary key is a constraint. So I'm writing here primary key. And the name of the column. We want student ID as the primary key. Now we are done. Run the query. Okay, we have some error over here. Some parenthesis is missing. Okay. I'm writing this again. Okay, there was one parenthesis was missing. So you see the result is showing that the table is created. So let's have a look. Go to the object browser and see if the student table is created over there or not. Tables. Yes, students table is created. If I click it, you can see this is the table definition with 3 columns. And here you can see for the student ID, we put the constraint that it should not be null. If I show you the constraints here, you can see here. The student ID is not null and the primary key is the student ID. And here you can see this, there is no teachers table, right? So I'm going to create this teachers table now. So SQL command. So for now the create table, teachers, teacher ID with the same, teacher name, and we have for the teacher, according to our lab, it is teacher's nationality, right? Okay, so run. Okay. Uh, Primary key is the teacher ID. Okay, table is created. Just look at again in the object browser. You can find the table over there also. You see the teacher's table is here. Now I'm clicking this and it shows the constraints we put on the teacher's table and all the columns you can see here. At the moment, there is no data in these two tables, right? Because we did not put any data in it, in these tables. Okay. So one more point over here is that we can see the table schema from our SQL command editor screen. We do not need to go back again and again to the object browser. So for this, we use the command describe the name of the table. Students You see, girls, the same uh, table definition is shown here also with the column names. Similarly, if I want to see the teachers table, so I can see here. Here one more, girls, think there are two ways to describe, right? Either we can write the full describe word or maybe we can use the short form. Both are acceptable. Both works. Now you see the teacher's table is also there. Okay, so here we are done with the two subtasks. We create the tables, we see how to describe the tables. Now I want to drop the teacher's table. Let's say I want to drop the teacher. I don't need this teacher's table. So I want to delete it. So if I want to delete the complete table with all its data and constraints, we use the DTL command drop, right? So run the command. Okay, drop, then table teachers. Okay, so the table is dropped. Now again, just to make you understand that you don't find here now okay, the teacher's table, right? Before it was there, now students just table is there. Okay, so one more thing for the DDL command. Now we are going to use the, alter some data in the students table. So once again, if we see the definition of the student tables at the moment, we have three columns: student ID, student name, and the student age. Now, many times, girls, when we create the database objects or the tables with certain columns, we need to maybe add a new column or drop already existing column, or maybe we make the changes in the data type or in the name of the column. So how we can do it? So first of all, I want we will see that out of these three columns, we don't want the third column, student age, right? We want to delete or drop this column. So how I can do this? So obviously it is already created. I want to make the change or alter the schema or the structure of this table. So what I will do, girls, I use the alter command of the DDL. So how we can write the alter command? We use the reserved word alter, table, then name of the table. What is the name of the table? It is students. And what I do, I want to drop obviously the column. So drop here, I have to write reserved word, drop what? I want to drop the column. Which column? Name of the column is student underscore age, right? Run the query. Now table is altered. So if I want to check it again, then I will write here. Now you can see the column student phone number is, student age is dropped. All right. Now, after that, now if I want to add some uh, column in my uh, now I want to add the phone number column for the student table. So again, I use this column, this command, alter table. It means I'm going to make the change in the uh, table schema. So I use the same command, alter table, name of this table, which is the students. Now, instead of drop, here now I will write the add because I'm going to add the new column in the in my table. So here you can see add column. What should be the name of the column? I have to give the name of the column. I want the phone number of the student. So name of the column is phone number. So girls, whenever we are defining a column, so we need to define the data type which the column will accept. So it's varchar 2. Run the query. Uh, Invalid identifier. Okay, here we do not need the column, right? Just add. Alter table students, add, then just directly give the name of the column. So table is altered. So if table is altered, just have a look again. Now the new column is added. Student phone number with the varchar 2 data type. Okay, so this is what about that if I want to delete some column or if I want to add some column, so I can use the alter command. Now what happens if I want to change, maybe already I don't want to add a new column, I don't want to drop a new column, but I want to modify the some column, like let's say instead of student name, I want that it should be displayed as the student full name, right? So how I can do this? I can again use the same command, alter table students. Now this time I will use because I want to, instead of student name, I want that this column name should be student full name. So I'm actually going to rename this column, renaming this column. So the activity is how alter table students rename column student. Which column I am going to rename? I'm going to rename the student name column. Now, what is the new name for this column? So I'm using the reserved word to. So it should be now student underscore full name, right? So rename column, table altered. So just have a look at how it is. Students. Yes, you see now it's student full name. Now girls, I want, now you here you can see the different other options are available. Uh, and according to that, you can see at the time of creation, we declared that the student ID is the primary key and it should not be null. So that's why it is not null. But the other two columns, at the time of the creation, we did not define that they should not be null. But now I want that the student full name column should not be null. The user must provide the value for this column also. So I want to make change here also. So how I can do it? I will use the alter table command, but this time alter table student, I will use the operator modify. I want to make the modify. What I'm modifying? I'm modifying the student full name column. Now, girls, I just want to make it not null. I'm not making any change in the data type. Although I can make it, but this time I'm not. But since we are making the changes in the column, so you must have to again write the data type. So same data type we are right here, but if you want, you make maybe some changes. Maybe you want to increase the length or what. Let's increase the length. But if not, then it's okay. But it's important that you must write the data type after the column if you modify the column. Now what I want that it should not be null. So I'm writing here not null. Run the query. Alter table students. Modify student underscore okay, wait, this is not null. Now table is altered. So one more time to see. Is it to have a look at the change? Yes, now it's student underscore full time. Length is changed to 50 and it is not null. So after creating the column, if you want to make any modification in it, we use the alter table command. So far we are done with all the basic DDL commands which we use for create the table. We describe the table, we drop the table, and we alter the table. And the alter has we discussed the 4 subtasks. So before I go to the DML commands, let's have a look at our exercises. So we are done with the part 1. Okay. Now here our practice activity 2. After creating the table, now we are going to insert the data in the table. Then we update the data. We will see if we want to delete some data, how we can do it, and we will select the data or records from the table. So all are these the DML commands, right? These all are the DML commands. So this is our table student ID with the student full name and the student phone number. We want to create 2 rows, right? We want to enter the 2 rows in our table. So girls, for inserting the data or creating the rows, there are 2 syntaxes, right? Number 1, the insert into is the reserved word. Then you have to give the name of your table. Then you have to give the column names. All the column names in which you want to insert the data. Then we have close the bracket, values, give the values for each column and make sure that the column and the values should match with each other, will be in the same order. Then the values should be separated by the comma, just like the columns, right? And this is how we are done. So actually, the point is, sometimes we don't want to enter the data in all the columns in our table. So for the selected columns, you have to use the first syntax, right? After the table name, what you have to do? You have to open the brackets. You have to mention the names of the columns separated by the commas in which you want to enter the data. Then reserved word values and then put the values. But in the case when you want to enter the values for all the columns in the table, then you can use the second command. Start with the insert into reserved word, name of the table. Now here you do not, since you are entering the data for all the columns, you do not need to specify the names of all the columns. You can directly start with the values. But again, you have to make sure you have to put the values in the same order as your table, right? For example, if here we have the student ID, then you must have to put the student ID first, the value for the student ID, then the value for the student full name, and then the value for the student phone number. So we have 2 styles of insert command. So first syntax we use to specify which column that will be add values to them into the table, and the values for each columns are listed in the same order. The number values are not enclosed in single quotation marks, as we know that numbers do not need to be enclosed into the single quotation marks. The second syntax we use to add values for all columns into the table. One precaution is the values for each column must match exactly the default order in which they appear in the table, right? As you see, if you are not clear about it, you can write the describe statement and check the order of the columns and then write the values in the same order. Clear, girls? So we are going to now create our first row. So here we are switching the screen. Now I'm here using the insert into name of the table students, Name of the column. How many columns are there, girls? There are 3 columns: student ID, student full name, and a student phone number. Now, I don't want to enter the phone number, right, for the first row. So that's why I specify the columns. Then values, the number value is, this is the student ID and it's a number data type, so we do not need to enclose it into quotations. But for the string values, we must enclose them into the quotation values. So run this command. Now you see one row is created. Now, if I want to see the data is entered in the table or not, I will write the select statement star and the name of the table from students. Now you see the select statement displays the rows from the student table, all rows from the students table. So since we just created one row up till now, the student ID and the student name and the phone number is not there. So this is how we can do it. Now we can add another row. Now this time we are using we are providing the all values, like insert into students. I want to add the values for all the columns this time. So I'm skipping this and just I will provide the values. So first value is for the student ID, second for the name, and the last is the student phone number. So since the student phone number data type is the varchar, and so I'm going to provide put it in the quotation marks. So let's say this is the, and name, we may change it. And obviously the ID is the primary key. It should not be the same. So we change it, the ID value for. You see one row created. Again, I'm writing the select command to check the data in my table. You see, now this row is, one more row is added. So this is how we can insert the rows. So you can insert any number of rows in the tables, in your table. Now the next part. The next part is that, let's say I want to, by mistake, maybe there is a mistake in the name of the student, right? Like Ahmad Abdullah. It's actually the Ali Abdullah. So I need to, correct it. So for this, if I want to make change in it, I will use the update command. So update is the reserved word. Update which table I want to refer, the name of the table, students. Now what I want to do, I want to make the correction in in this name, right? It's not Ahmad Abdullah, it's Ali Abdullah. So what I will use here, I will use the set, which column? Student underscore full name, right? The name of the columns equals to, now what should be the value? Should be quotation, Ali Abdullah. Okay, guys, here one more important thing. If I write just this part and run this query, it will change both or all the values for the student full name, right? So it is important to select specifically the row. I just want this student's name should be Ali Abdullah. If I will not select the rows, it will change the name of all the students in my table. So for selecting the rows, we use the where clause, right? So where with the followed by the unique attribute, which is the student ID. You can use any unique attribute, but it's better to go with the primary key, which is the student IDs, to make sure that only the required data, record is deleted. So what is the ID here? It is 103020. Run. You see one row is updated. So let's check. Yes, the name is updated. Ali Abdullah. Okay. Now the last is maybe I don't want any, you know, I don't want the record, this record. So I want to delete some record. So for this, we use the delete command of SQL. Delete what from name of the table, students. Now what I delete, I want to select some specific record. So I use the where clause followed by the primary key or some unique attribute. Oh, okay. We should have to give the name value for that. Student ID 102030. So one row is deleted. Let's have a look. Select star from student. You see, Ali Abdullah's record is deleted. So this is all about our today's lab. Now I want you to now, we are done with all these exercises. You have to repeat it and do these lab activities and submit through the Blackboard. You need to write all these queries, take the proper screenshots, and then submit it. So we are done.